Hello, we are Crypto Knights, and today we will be demoing our class project. In our class project, we set out to make a website known as the Graph Attack. And in this website, you provide us the input features and parameter values, and we provide you with three kinds of awesome analysis. I will be showing you the different things that we can provide with this. So this is the homepage, which lets you take three inputs. First is a file. This essentially takes the attack graph in XML format. The second value is essentially the default value of the nodes in your attack graph which do not have a vulnerability associated with it. We need these because to calculate the cumulative and conditional probabilities of all the nodes in your attack graph, we have to calculate the paths. And in those paths, there might be nodes which do not have any vulnerabilities associated with it. In those cases, this gives you a default value. The third value says that in your entire system, you might have a lot of nodes and you do not have enough budget to place an intrusion detection system for each node and each vulnerability. So you tell us how many vulnerabilities you can address or place detection mechanisms to detect, and we provide you with the game theoretic solutions. Once you upload this, a call goes to the backend and calculates all the three of these things. The first on this side shows the probability of which a goal state can be reached. In the example that we chose to give, the probability is 0.667. The second essentially shows that what is the CV that if you remove will give you the highest return of investment. This is essentially a little diversion from the normal countermeasure selection techniques that we have seen in cybersecurity. What we try to do is we try to take out each vulnerability from the attack graph and find taking out which vulnerability gives you the highest return of investment. In this case, it is this vulnerability that you see here. And the last one is essentially a game theoretic strategy that you get, which essentially says that you can place 3 out of all the vulnerabilities that you can identify. In this case, we see that there were 5 vulnerabilities in your attack graph.xml, and we have chose to place 3 vulnerabilities, 3 intrusion detection mechanism systems at any point of time. And these are the corresponding probabilities associated with it. We also provide you an extra file which has the JSON values of all the nodes in your attack graph.xml, which essentially states with what probabilities these nodes can be reached and what are the different paths to reach these nodes. We will also show you a little thing where, let's say, if you actually land up removing this vulnerability out of your attack graph.xml, what happens then? So let's say you have fixed the vulnerability that you have in your cloud system, and you want to know which is the next vulnerability to fix. So we have another file which essentially takes out that vulnerability and makes the attack graph. We again enter a probability value for now 0.5 and say to here, and we upload. In this case, if you notice that the probability of reaching the goal state still remains at 0.667 because there were essentially 2 vulnerabilities which had the same CVSS core values. But if you see here that the 52th vulnerability, which was denoted by node 52, was already removed, and this time it's telling you that you should remove this new vulnerabilities. These files are again the same, so we won't go and show you these again. Thanks a lot for listening to us. Thank you.